Welcome to clickmyproject.com. Our product title is a single-ended with dynamic feedback control 80 subthreshold SRAM cell. Now we are going to see our product abstract. A novel 8 transistor static random access memory cells with improved data stability in subthreshold operations designed. The proposed single ended with the dynamic feedback controlled 80 static RAM cells enhanced the static noise margins power supplies. So the portable microprocessor controlled device contained embedded memory which represented a large portion of systems on chip. These portable systems need ultra low power consume circuits to utilize the battery for longer durations. The power consumptions can be minimized using non-conventional device structures, new circuit topologies, and optimized architectures. The voltage scaling has led to circuit operations in sub-threshold, the minimum power consumptions, but these disadvantages of exponential reductions of performance. The circuit operation in the sub-threshold have path towards ultra power embedded memories, mainly RAM and SRAM, static RAM, in the subthreshold, and the data stability of SRAM cells is so problem and scaling the MOSFET and sub-nanometer technologies. Due to this limitation, it's become the difficult to operate the conventional 80 and 60 and 70 whatever ultra voltages power supplies. In addition, 80 has so problem to read disturb the basic and effective way eliminate this problem to decoupling the true storing the node from the bit lines during the read operations. This read or decoupling approach is utilized by conventional 8 transistor for that the read decoupling 8 transistor cells with offer read static noise margins with the hold static noise margins. However, we are using the 80 suffers from leakage introduce the read path. This leakage current increase the scaling and increase the portable failed read-write operations. Similar cell maintains the cell current without disturbing the storage node in the our proposed systems. Now we are going to see our product flow diagram. This is our flow. First of all, we are designing the 8 transistor SRAM. First we are WBL and WWL. So WBL right bit line. This is we are giving the bit line. So single ended in 80 bit cell. So we are giving the right process on the bit line. We are giving some data input and then power source something where whatever the WWL. So this is the enable functions for the process the RAM store. So whatever input we are giving the bit data, and then this is the functionally which time we have using the store the process. So WBL the right bit line we are giving the some input, and then WWL the enable functions. So whatever timing we have to read in the our memories processor. So we are giving the some data for zeros 0000 so 1. So whatever zeros are 1s, and WWN which time enables is going to the read the bit lines. It will be stored, and then read path functions. The read path functions is going to the bit is one transistor which the FCS1 feedback control signals. This functions is enable the which time. So we are the read bit line scheme is process going there, and then address selections process. The address selections process is going to that the process which time we get the enable functions. We go into the write the functions enable. We are going to read the functions. Finally output store in the data bit. We are going to the read bit line. this function we are going to store the functions and schematic the analyze, and then we say get the process against variations and all operations, additions, read stability of single end, it is comparisons, conversion. So this lines is of analyzed then process, and then we have set selections bit processor. So whatever the 8 sub threshold 8 SRAMs is operate the sub nanometer technology node the ULV. This 8 SRAM cells use a single end write with dynamic feedback cutting to enhance the dynamic read decoupling to avoid the disturbs. So due to the read coupling mechanisms in going to the selection line bits, so this process we are using that memory store in the each time RRB and WWL. Now we are going to see our product running procedure. So this is our tool for Tanner CMOS technology AS editor. So now I have to open to my project design. Okay, open design. So select the path. So this is our design. So I've selected and okay. So then this is so I have to hide my design. I have to this is selections. So this is simulation setup. So here it's very important for transient Fourier analysis. This is only the check clicked, and then is a double click and then setup. This time stop time is 200 in nanoseconds, and the maximum time setup is 1 nanosecond sprint time. This is rules setup. Okay, click. Then I have to go to my start simulation, running the simulation part, and then going to the this is how to pay for that. This is so here WBL and RBL. So write the bit lines. So this is I give the input for 0 1 1 0. This is the input for get the voltage. This is a voltage, zeros are sun 5 voltage. So this is the input voltage, and then what our time for I have to fix it WWL. This is 0 to some enable pin, and then this is off time. This process we are going to store the this is the input full time or zeros or ones or zeros bitwise like voltage, and this is the enable function. This is enable, and then this is the disable function. So whatever time I give the enable function, this time the output will get the RBL. This time we are getting the output. So this is the output process, say enable. This is RWL, and then read bit line. So this is the output for the process. Out time whatever time bit I have to enable, this process enable, and then this process is disabled. This process not stored. So this is the output functions. I just have to close this process, and then I'm going to, so power calculations is very important. So power calculation have to going to export my file, export file, and export as spice. So it's going to say export, and then I'm going to spice. So this process I'm going to open. This process I'm opened. So here, so I'm going to power calculation. So what the process, which process I'm going to, so I need this process power calculation I need. So copy and paste here, and then this is the parameters named noted, so power, and get just I will save it and run here. So this is the power calculations. I am using the power calculations in this process.